Grounding a satellite dish to a cold water pipe may provide some protection against lightning, but it is not as effective as grounding it to a ground rod. A ground rod is a metal rod driven into the ground, providing a low resistance path for electricity to flow into the earth. The National Electrical Code requires that satellite dishes be grounded to a ground rod. The ground rod must be at least 8 feet long and must be driven into the ground to a depth of at least 2 feet. The ground rod must also be made of copper or galvanized steel. Here are the steps on how to ground a satellite dish to a ground rod. Firstly, dig a hole at least 2 feet deep and 6 inches wide. Secondly, place the ground rod in the hole and drive it into the ground using a sledgehammer. Thirdly, connect a bare copper wire to the ground rod using a grounding clamp. Fourthly, run the copper wire to the Koch's grounding block on the satellite dish. Fifthly, secure the copper wire to the Koch's grounding block using a grounding screw. The purpose of grounding is to provide a safe path for electrical current to flow in the event of a fault, such as a lightning strike. This path helps to minimize the risk of electrical shock and damage to equipment. Grounding systems are designed to direct stray currents to the earth, where they can be safely dissipated. There are several types of grounding systems, including equipment grounding, system grounding, and static grounding. Equipment grounding connects the metal parts of electrical equipment to the grounding system. This helps to ensure that if a fault occurs, the current will flow to ground and trip a circuit breaker or fuse, disconnecting the power. System grounding connects the neutral point of an electrical system to ground. This helps to stabilize the voltage and reduce the risk of voltage surges. Static grounding is used to prevent the buildup of static electricity, which can be a hazard in certain environments, such as those where flammable materials are present. Grounding is an important safety measure that should be implemented in all electrical systems. It helps to protect people from electrical shock and to prevent damage to equipment. The National Electrical Code, or NEC, provides detailed requirements for grounding electrical systems. These requirements are based on established safety principles and are designed to ensure that grounding systems are installed correctly and function effectively. The NEC specifies the types of grounding electrodes that are permitted, the size of grounding conductors, and the methods for connecting grounding conductors to grounding electrodes. It also addresses the grounding of specific types of equipment, such as satellite dishes. In addition to the NEC requirements, local codes and regulations may also apply to grounding systems. It is important to consult with a qualified electrician to ensure that grounding systems are installed in accordance with all applicable requirements. When selecting a ground rod, it is important to choose one that is made of a suitable material and is of sufficient size. Copper ground rods are generally preferred because of their excellent conductivity and resistance to corrosion. Galvanized steel ground rods are also acceptable, but they may not last as long as copper ground rods in corrosive soils. The size of the ground rod should be based on the size of the electrical system and the soil conditions. The NEC provides guidelines for selecting the appropriate size of ground rod. The depth to which a ground rod must be driven into the ground is also specified by the NEC. The minimum depth is typically 8 feet, but may vary depending on local soil conditions. The purpose of driving the ground rod to this depth is to ensure that it makes good contact with the earth and provides a low resistance path for current to flow. The connection between the grounding conductor and the ground rod must be made using a listed grounding clamp. The grounding clamp should be compatible with the materials of the grounding conductor and the ground rod. The clamp should be securely fastened to both the conductor and the rod to ensure a reliable electrical connection. The grounding conductor should be run in a straight line from the grounding clamp to the equipment being grounded. The conductor should be protected from physical damage and should not be subject to excessive tension. The grounding conductor should be sized in accordance with the NEC requirements. The size of the conductor is based on the size of the circuit being grounded. The grounding conductor should be large enough to carry the maximum fault current that is likely to occur. The Koch's grounding block is a device that is used to ground the coaxial cable that connects the satellite dish to the receiver. The grounding block provides a convenient point for connecting the grounding conductor to the coaxial cable. The grounding block should be located as close as possible to the point where the coaxial cable enters the building. The grounding block should be connected to the ground rod using a grounding conductor that is sized in accordance with the NEC requirements. It is important to inspect grounding systems regularly to ensure that they are in good condition and functioning properly. Ground rods should be checked for corrosion and damage. Grounding conductors should be checked for loose connections and physical damage. Grounding clamps should be checked for corrosion and tightness. If any problems are found, they should be corrected immediately. If you are not comfortable working with electricity, it is best to hire a qualified electrician to install or inspect grounding systems. Electricians have the training and experience to safely and effectively work with electrical systems. They can also ensure that grounding systems are installed in accordance with all applicable codes and regulations. When grounding a satellite dish, it is important to consider the location of the dish and the surrounding environment. If the dish is located in an area that is prone to lightning strikes, it is especially important to ensure that it is properly grounded. If the dish is located near trees or other tall objects, it may be more likely to be struck by lightning. In addition to grounding the satellite dish, it is also important to ground any other metal objects that are located near the dish, such as the mast or the mounting hardware. This will help to create a more comprehensive grounding system and further reduce the risk of lightning damage. The NEC also addresses the grounding of other types of communication equipment, such as antennas and telephone lines. The grounding requirements for these types of equipment are similar to those for satellite dishes. It is important to consult the NEC to determine the specific grounding requirements for each type of equipment. Grounding is an essential safety measure that should be implemented in all electrical systems. It helps to protect people from electrical shock and to prevent damage to equipment. By following the NEC requirements and consulting with a qualified electrician, you can ensure that your grounding system is properly installed and functioning effectively. In the context of lightning protection, a properly grounded satellite dish provides a low impedance path for the lightning current to flow to ground. This helps to prevent the lightning current from flowing through the building's electrical system, which could cause damage to equipment and create a fire hazard. The ground rod acts as a point of contact with the earth, allowing the lightning current to dissipate safely. The grounding conductor, which connects the satellite dish to the ground rod, must be of sufficient size to carry the expected lightning current. The NEC specifies the minimum size of grounding conductors based on the size of the service entrance conductors. In some cases, it may be necessary to install multiple ground rods to provide a more effective grounding system. This is particularly true in areas with poor soil conductivity. The ground rod should be spaced at least 6 feet apart and should be connected together with a grounding conductor. In addition to grounding the satellite dish, it is also important to install surge protection devices on the incoming power and signal lines. Surge protection devices help to protect sensitive electronic equipment from voltage surges caused by lightning or other electrical disturbances. Surge protection devices should be installed at the service entrance and at each point where power or signal lines enter the building. When selecting surge protection devices, it is important to choose devices that are rated for the expected surge current. The surge current rating is a measure of the amount of current that the device can safely handle. It is also important to choose devices that are listed by a recognized testing laboratory such as Underwriters Laboratories or Intertek. Lightning protection is a complex subject, and it is important to consult with a qualified electrician or lightning protection specialist to ensure that your building is properly protected. A lightning protection system typically includes a combination of grounding, bonding, and surge protection devices. The system should be designed to protect the entire building, not just the satellite dish. The cost of a lightning protection system can vary depending on the size and complexity of the building. However, the cost is typically a small fraction of the value of the building and its contents. In addition to protecting against lightning strikes, grounding can also help to reduce the risk of electrical shock. A properly grounded electrical system provides a low impedance path for fault current to flow, which helps to trip circuit breakers and disconnect the power in the event of a fault. This can prevent electrical shock and reduce the risk of electrocution. Grounding is an essential safety measure that should be implemented in all buildings. It is important to have your electrical system inspected regularly by a qualified electrician to ensure that it is properly grounded and functioning safely. When installing a ground rod, it is important to avoid damaging underground utilities, such as gas lines and water lines. Before digging, you should contact your local utility companies to locate any underground utilities in the area. You should also wear appropriate safety gear, such as gloves and eye protection, when driving the ground rod into the ground. If you encounter any resistance when driving the ground rod, you should stop and investigate the cause. It is possible that you have hit a rock or other obstruction. You should not force the ground rod into the ground, as this could damage the rod or the surrounding soil. If you are unable to drive the ground rod to the required depth, you may need to relocate it to a different location. It is also important to ensure that the ground rod is properly bonded to the building's grounding system. Bonding is the process of connecting all metal parts of the building to the grounding system. This helps to create a more comprehensive grounding system and reduce the risk of electrical shock. Bonding should be performed by a qualified electrician. In summary, grounding a satellite dish is an important safety measure that can help to protect against lightning strikes and electrical shock. A ground rod is the preferred method of grounding a satellite dish, and it must be installed in accordance with the National Electrical Code requirements. It is important to consult with a qualified electrician or lightning protection specialist to ensure that your building is properly protected.